maybe Tony, you can start first.
Hi everyone, my name's Tony Burrows and I'm the Heritage Team Manager. So it's my responsibility to put these events together, put the team together and coordinate between the organisations at the event place and the factory. So yeah, I'll hand over to my technical partner.
Thank you. Hi there, so I'm Ian Kelly. I'm the Heritage Electronics Coordinator, but also the electronics engineer for the car. So, been in F1 since 2001, and then my now focus is doing show cars, heritage cars, and totally supporting the events and building the cars before we come to these events.
Hi all, I'm Stefan, an engineer from HTEC. My background is I started in Formula Student as an engineer long time ago now, and currently I'm working in HTEC on mostly electric vehicle technology. And that's it.
Hi everyone, I'm Vanya. I work as senior software engineer and team lead in our company, and I mostly work on developing advanced driver assistance systems with a special focus on safety when working on them. Thank you.
So thank you very much for the introduction, and I guess we can start with the questions. For me, the first one which pop-ups is you have plenty of these events over the years, right? How do you prepare for these kinds of events or a race weekend when it comes to setup of the car and challenges which are brought by different kinds of, let's say, tracks or cities that you find in?
Yeah, so when we started doing shows, we did a sort of like got together and say, right, let's do a blanket build spec of the car, because the main thing for it to be is reliable. We don't need to like have it, the performance there. So we then started looking at, right, let's reduce the amount of sensors on the car and just have what we needed and any like systems on the car. The current car we have here had like the old kinetic ERS system. So we didn't need that because it was just a boost system. So examples like that, so we took that off. We added like a fan system on. So because we haven't got the airflow, because sometimes we're only doing donuts, burnouts. So we haven't got the airflow to go through the car. So we added a fan system. So then we try and get as much information ahead. And Oscar or Tony will come down and say, oh, by the way, this car is running up a mountain or on like rough terrain or something like that. So we'll just... we normally like try and do a standard setup and make it higher, so it's like because we don't need the downforce and etc. like that. But then we have problems of like when we went to Kitzbühel and did in the snow, it was like -11. But we've never raced or anywhere like that. Even our partners with the oils and things like that, we were telling them, what's the oil like at that? We didn't produce the oil to run at that, so we don't know. And so things like that. So you just try and preempt as best as you can, but again, you don't know until you get there. But then it's just basically do the same procedures as you would at the track about firing the car up, getting it warm, getting it ready, because it's not just a car you can turn the key and drive. You still have to treat it like the tool it is. So it's very temperamental. Some of the parts on there was designed only to do certain a narrower limit and a narrower life in. So you just got to still maintain that car like you would at a racetrack. And because again, you don't want it breaking down. Things will happen, but you've just got to try and preempt and just prepare that car that's going to be reliable.
Yeah, even if it's not a race weekend, still a lot of challenges in front of you, as I can see. Yeah.
And the tougher, I've always get asked the questions like, "Oh, you must be great because you can just come to a city, sit back and watch the car going up and down," and go like, "Well, it's more stressful for me because at a racetrack I'm in the middle of like 5 guys and we're all on intercom, we're all looking at the data, and then we're chatting, saying, "Oh, have you noticed that? Oh, yeah, it's okay. Maybe it's because of that. Who's that? Okay." Or you could warn, and if it's just in the practice session, you could just say to your engineer, "We need to bring him in to have a look." Or we'll have a look in the next turnaround. When I'm here, I haven't got the controls engineer or everything sat next to me. You're on your own, and we don't run live telemetry here.
Yeah.
So we're doing the runs, and then in between the next run, we quickly download it, quickly scan. Your experience gives you a sort of muscle memory as it's being offloaded the car. You can see if there's something not right or you need to adjust something. But it's for me it can be slightly stressful because you still sometimes we're in a narrow window of when a 15-minute session the police won't open the road again and that's it and you're done. So if you're saying, oh wait a minute, there's a problem, I need to change something, you've missed your slot, and then that's what we're trying to avoid.
So not that easy as someone would think of. Okay. And you mentioned some parts, data and everything. Tony, you are with Red Bull for years now, and since the beginning of the history and everything. How much the technology changed there from the, let's say, sensing perspective, telemetry systems, how this is now involved, and what kind of systems now you're using for collecting the data?
Basically, the car itself has changed enormously. I mean, I started in Formula One in 1988, so it's, the cars are, the cars are a lot different. But what's actually happening electronically within the car, I mean, that's where it's made its biggest growth, is probably more Ian's field, so I'll quickly hand over to him.
Thanks a lot.
Yeah, what started happening is that the FIA would then say, you are running this type of system. So that one then, it took a lot of pressure off the teams and the software developers and everyone trying to integrate it all, because that company will come with integrated systems. So they're doing all their R&D, they're doing all their integration together. So the tool we use when what we call it real time, when we plugged into the car over Ethernet, is one piece of software, and then the data acquisition afterwards is another piece of software. So, but they're all designed to work together. So the problem was in previous years where you'd have other certain software that you were trying to implement it into that. And as the times go over, where you started with your 16-bit laptop, and you wasn't looking ahead thinking, how's this software going to need to be advanced, and then your new piece of software comes from that company, and it's like you're running on a 32-bit, something like that. So it's just like, but luckily we've got our fit labs and stuff and developers who will look into it, and you can only reply back saying, I'm having an issue with this, because even now with the software we've had from these companies that every team has to use, you're still getting bugs, you're still getting updates. It's like probably you get another, say, for Canada or the one after, you will get an update from them to update software sort of things. But it has continually changed, but the platform has stayed the same, that we're all using the same standard ECU.
So that makes things a bit easier for you as an engineering team to really focus on some other things.
And I mean, and it's still different how you will use it differently to other teams and certain ways. But yeah, it's probably stops not going crazy, but you're trying to do more than what you need to do, and you can overcomplicate it and stuff. But every department wants more data. If you said to every department, what sensors do you want a car? It'd have to be a truck. It wouldn't be able to carry it all. And then when you'd say to them, right, can we reduce it? The login rate, the size of the files are coming off too big or something like that. They're all just like, well, we need them all. Otherwise, we wouldn't put them on there, sort of thing. So it's always part battling, but reasoning. And of course, you want to give them more data and you want to give them more channels, and but you still have to keep sort of down. And then it does get limited. The different types of ECUs that we've had over the years. There's two different types now that we run on the current car, but it's still the same manufacturer. But the processing rate is quicker. The size of the files or the channels can be logged is more. So, but you will always fill the logger and the login table, and you will just be like, and they'll just say, well, I need it.
And I like the idea that you mentioned experience and how you utilize the technology. So this is where I can really find the similarity. I guess you want really to have a top talent in your team, which can actually bring or gain the advantage. So this is what we also feel here in the software industry, where everybody wants to collect the top 5% of the talent, because this is where you can explore other possibilities utilizing that technology. So this is where I can find a real nice
Definitely. And you want someone to come in and have ideas, but you don't want anyone to come in and try and change everything. But it's always nice to have, again, I've been there too long, so I might not be stuck in my ways. But then you get someone come through and say, have you tried doing it this way? And you're like, we have tried that. It doesn't work like this because of this. Or you will go, no, actually, it's a good idea. Just give it a go. And then we'll do it on the side. We've got a thing called a car in a box, which is a car loom with an ECU sat in a box. But it's a full car. So you've got all the analog channels that you can plug into. But then you can sit there and have that car on all day, log in, doing things. You don't need it to run, but you're looking at it to see what you can develop different things with. But so you will always look and try and develop even just small software programs to help you of that main system. You won't be able to change that or the embedded code on that, but you can just keep it as it is, but make it a bit more understandable and quicker for yourselves.
Nice. And Stefan, hearing this, how does this resonate with your experience in Formula Student and the challenges which you have there? How they compared with what Jan mentioned now?
It's a bit like there is not that much money, and there is no standardization of the telemetry system. So, for example, we did a whole telemetry system for ourselves, but there is a problem with the sensors. Everybody wants every sensor, and no, there is not that much space on the car. There is not that much electronics. Too much electronics on the car weighs down, and there is a problem of people. Those are small-scale students' projects, and you can get all of the data, but you don't have enough people to look over all of the data. So that's also a problem.
So you don't have a NASA operations space like Red Bull has for doing the analytics and analyzing things.
For a student, you usually just phone the guy and say, Johnny, we need a new tire.
Yeah, different challenges, but I guess a lot of nice experience here. And you also mentioned bugs happening, and I think a lot of people here, especially we are in a software company, they know about the bugs, so they don't want to have them, but everybody has some bugs. Can you recall any seemingly small bug or any issue which from the racing weekend or these kinds of events that actually made a big problem for you? Like you mentioned, 15 minutes window, do some things. Are there really small things that later on you see, oh my God, this happened and it took us days or to figure out, or hours or something like that? Does this happen a lot?
Been something that you've put on the car that has has interfered and caused you a problem, because at this level it shouldn't really happen. But we've had weird things happen on the car. Was it a test where there was a pressure tap on the front wing, so they had chafed through and was causing noise on the gear shift. But at that voltage, when the car was going fast, it was sucked down. The car started changing gear itself, and the driver was like, "I didn't change. Back off. There's something not right." And then can't see nothing, go again. As soon as he then put the speed up, he's got, "No, it's changing for me. What's going on?" So then quickly you're scanning everything to try and see what it was, and then somebody spotted that, "Oh, have you noticed there's something wrong there? It's conflicting," straight away. And it was something that you would have never even, through the wiring designers and things like that went, and it was just one of those random things. But as it pulled down and got to 3 volts, it was a selection for a gear. And so it was quickly, okay, new nose cone, and then straight back out. Something that you guys wouldn't have a chance to do, because when you're looking at hundreds of thousands of pounds on your nose cone, then you can just then do it and off you go again. But that was totally bizarre, and we were all scratching our heads going, but luckily someone spotted it. Have you noticed on this channel that is interfering with that? That's the only sort of maddest one I can remember.
Nice. And you mentioned also in that situation, driver is saying, okay, I didn't do anything. What is the controllability that the driver now, they have they can switch modes? they really can do something?
Another fact is when they've gone through with the performance engineers and the controls engineers, so they are, they've had a massive conversation about, and then they've given them loads of options of different setups within the car, because you can't tell him what to change and when. But if you've got a predetermined setups in the car, then you can just advise, why don't you try this particular setting on this? He then realizes what you're on about because you've had that conversation, and then he will like sort of try it, and then but they had a run plan and come through to say, let's try this because it might be an FP1 that they've they haven't been there for a year, so and then it's a different car, so let's go and try that. And then actually where last year the car acted better in this mode, but it's not.
It depends on the track and depends on the tire. Yeah.
The track could be resurfaced, could have even rained, and things like that. So they will have it all set up between them, and they will go through that run plan and then try it, and then that will all change again because they'll do now a new tyre compound and then go again. But then they're constantly, so the more they can do on that is the more the data that we can get back. But then they'll go and change, either a suspension setup or a wing setup again. But then you've got to try and transfer that over of how it would be on the different compounds. So, but again, you've got the whole engineering department that have already got all this in place. They've got baseline runs. They've got the simulator work that they can back up. Hopefully it matches, not always, but modern things don't. And then again with like wind tunnel and CFD. So they're all trying to correlate that, them 5 factors overlapping. And then if you get it right, like we have in a couple of years, then you can see the results on the track.
Yeah, thanks. And Vanya, controllability is also something which is important, I would say, in automotive, and especially when you have some assistance system for autonomous driving. And of course, safety is there. What happens there? Like how much controllability is important, and if something goes wrong? And for course, we heard a lot of sensors. We know that there is a lot of sensing technology in vehicles as well. They have to be reliable. So how you cope with that and compare it with?
Yes, when developing some ADAS system, controllability is one of the 3 most important factor. So when you analyze possible crashes and what could happen then, so it's about severity, which is amount of injuries that can occur when accident happens. The other factor is exposure. How often can it happen? Is it every time when we go to road, or it's once in 7 days? And controllability is the third factor. So it's about what the driver can do when the dangerous situation happens. And when developing these kind of systems, reliability is one of the crucial factors. So when we are choosing which kind of sensors, which kind of microcontrollers we use, we have deep knowledge about that by looking into manufacturers' data sheets. So we can know which sensors are more reliable than others. Also, we have special safety mechanisms depending on sensors. So it's not just the sensor tracking what is happening. We also need to have information how sensor is performing. Is it in a good state, in good mood? So we also have safety mechanisms during startup of system. We perform self-checks, different kind of them, and also during runtime periodically we do tests of the sensors.
So you cannot also avoid the data. Data is crucial here in this.
Yes.
I know that there is like billions of data points that you have over the seasons or weekends, terabytes of information, including also video, support information. What are the most, let's say, important data that you want to get out of the vehicle that actually can tell you? I know that everything in the car is now connected. You have a lot of issues, communication channels, and everything. What are for you like the most important information in getting from the vehicle?
because I only do reliability mainly, so we just want to know that something will stay reliable and like you determine when that's going to fail.
Like predictive analytics maintenance or something like that.
Yeah, so we'll put in a period of time or mileage that it's easy with a race car because it's constantly on the track, so it will like when it's done like 750 kilometers, you can say that part will go back through to wherever it was built to have a service cycle and schedule sort of thing. So they're easy to put on because then and they'll only have a maximum life, and then once that's been reached, and it could happen in any 3 or 4 races, then that's that part done for racing. But you might use it for doing on test cars for tyre tests, because you can put a test life a bit higher. And then some parts you do want to try to see how long you can go with it. But again, if it's the one that will fail, that it's not going to stop the car, because some are only monitoring. You wouldn't do that with a control sensor that you need for gear shifting or anything like that. So Moog valves and stuff, you wouldn't you don't risk anything. And then with the show cars, I mean, sometimes we only do 10 kilometers over 3 days, but the car has had a bit of a hiding, and it's been. So we will just, after 3 events, we will just strip it, but we're periodically like checking oil. So, and like luckily designers have chosen different metals that do the same sort of things. So when the oil sample comes back, if one of them is high content of a particular metal, then you can point it to a particular piece in that gearbox or a bearing of something. So you haven't just got a high content of something is wearing down. You can actually pinpoint it and say, right, okay, we need to take this gearbox out of the pool or swap it, and then or do the routine maintenance on it, sort of thing. But again, there's nothing really that you just like constantly looking at, because you've got so much to look at, and you're still looking at your core parts of the car to keep going. For show cars, it's clutches, because they're not designed to be constantly engaged and disengaged. Doing donuts for them is just a nightmare. It's the torque going through them, and they don't get hot quick enough. So they are, because it's carbon, so they wear more when they're colder. And you might look good seeing the car screaming around, but we're back there going, oh no. But yeah, but routinely we will still do that maintenance and keep an eye on what the values are of that.
I like this with reliability, because I spoke with Tony. We brought it like half an hour ago. We were talking about back in 25 years ago. There was like, if you look into the table of the race winners and there's a lot of like did not finish DNF things. So how much of this technology now, Tony, that you have these days, help you actually to make the cars so reliable? We don't have that much DNF in the racing today as we had like 25 years ago. How much data helps you in that?
Mainly is because the rigs have improved so much. I mean, we can run a whole season on a rig by just leaving a car running. We can run gearboxes. The gearboxes now, we used to build a gearbox years ago, put it on the car, go out there for the first session of a race, check through all the sensors, make sure everything's okay. After 2 or 3 sessions, you might spot a problem, so you might have to do something about it. So the cars are very temperamental, whereas now we'll put it on a rig and we'll run half a race distance on it straight away, and it will run without a blemish, no problems whatsoever. So we can put it on the car wholeheartedly, knowing you will not get a gearbox failure. You don't get failures like that anymore. They don't happen. And also, as I explained earlier about just the heating problems that you used to get with cars of overheating, whatever, we run these cars on rigs where the engine's running. We have an air supply feeding in the front, and we can measure how much that lowers the air temperature in the car, and we can make changes to the airflow within the car so it gets to the right temperature. So when we know what the weather is going to be like next week at this race, so we can put the car on the track, he can go out there and the car will achieve exactly the temperature we wanted it to do without having to keep coming in and out and messing with it and playing with it and trying to find the right temps. And the same with the brakes. We can simulate a certain track and then change the material and simulate it again, and come up with the best overall for that particular driver. And then we've got the simulator software that's gone crazy now. I mean, it's so realistic. You know, we have a driver strapped in a chassis, suspended off the ground with a 360-degree view, and he can drive a car, and he will feel that car because the car's operated on rams. He will feel that car operate, and he'll be able to tell you if we need to go up 1 or 2 clicks on the front wing. We'll make those changes digitally. He'll go out and do another lap and say, no, that's too much. We need to go back on the bar. And we can develop a setup for the car before we got anywhere near a track. And then we put it on the track. He goes out there and says, yeah, the car feels good. I mean, that didn't happen years ago. That's a relatively recent thing.
And I think those simulators and everything which you have is much better than the games that we have these days, much realistic. So
they are much better than obviously the PlayStation games, but that's where it all started. You know, like kids like Max, when he was younger, he used to play on the PlayStation just to keep himself sharp.
You still do that a lot, right?
So now they just got more and more accurate. So now we know that if that says the car's doing this, we know that it is doing it, and we'll make changes to the car. He will go out in between sessions and have a little go. You know, he will simulate stuff. And we have a driver back at the factory over the race weekend, and he's constantly listening to the problems that Max is having. They'll be dialing them into the simulator, and then he'll be doing laps back at the factory, sending the information that he's learned back, and we'll put it on the car for the next session. So it's a different world now.
Yeah.
We went from a team of 70 people to about 1,200 that we got now. That's the difference in the years.
Yeah. Technology is growing, and I guess advancements in technology are pushing you also to make bigger teams and really cope with that technology. You also mentioned like you have a team back in the factory. How much fast the data are going there? Like is it like a milliseconds that now you get the data directly from the racetrack down in the factory? I mentioned this NASA look-like things. I saw a picture a few years ago. So how much of the team there is? How fast they are getting the information, and how much of the feedback from any kind of data analytics that you do comes to do any kind of split decisions that you need to do it?
It is quicker. Well, it's not as quick as you think, because it's still just under a second of it happening on the track to how you're seeing it. So sometimes he is talking about there's something not right as it's coming through. So I think, and then it's like you have a twin setup sort of thing. So you have data servers at the circuit, which is feeding all what we call clients, and then when you're back at the factory on the ops room, we have a similar sort of setup of so you're trying to reduce the bandwidth between the track over fiber optics back to the circuit, back to the factory. So then our data servers are getting the raw data and producing it through. But it's still a second for a human, I think, to respond is still pretty quick, but everyone always thinks it's like instantaneous, but no, there is a little bit of delay.
So I guess the communication is one of the crucial things in everything.
So the guys there, which is like you just take it for granted, and it's so clear. It's like you were in front of me, and he could be in Australia. I'm in Milton Keynes in the UK, and we're just chatting around different things like that. And then you could just be like, and you will just discuss what's going on and stuff like that. So, and then there's different groups that you can be in, and you're all, basically it's literally like you're in an open room together.
Mentioning this because we are working in the automotive industry, and for us, especially in the safety area, timing requirements are also crucial, right? Because we have different kinds of fault-tolerant times in milliseconds. We are talking about also motor control in microseconds, having some sensorless systems, all these things. It's really important to really obey to those timing requirements. You guys agree with how challenging it is now to achieve those kinds of things in the automotive industry?
As the technology improves, the timing requirements are more stricter and stricter, because, for example, the more control you want, you need to do it in less time. Like you need to have some problems. For example, if you're going 60 miles an hour, you have more time to respond than if you're going 150 miles an hour. And a lot of the current development automotive is going through a phase of going everything to simulations, because hardware became hard to get by a few years ago during the virus. And also to test, like, for example, the autonomous driving. Like you said, you have like a full car setup in a box, and to test autonomous driving, it is good that we don't need a driver. So we don't need that part. But checking in software, does it do correctly? Like the simulations, the games are also a thing that are coming to us in development through, for example, you mentioned F1 game, I mentioned Grand Theft Auto. You drive a car, there are pedestrians, there are signs and everything, and you can spin up all of the logic in a cloud or somewhere remote, so it can go and try a lot of things. So you can learn, you can tweak it, you can tune it without endangering anybody. And you can have a lot of like the track time up there somewhere, and you can just make the car, make the autonomous driving or some ADAS, and with a greatly reduced time on track, you can go through all of the test cases and everything without spinning the loop of development from zero.
Cool. And we talk about the data, right? Analytics is a big part of it. And you mentioned like 1,200 people working there. How much of that team is actually focusing on data analytics? What kind of technology is being used today in Formula One, like machine learning, AI? Is this something that is part of your team? Because you want to have some data to maybe boost the performance, right? So what's happening now in Formula One these days?
I wouldn't really know from that side of it, because we're just purely focused on our departments and the job in hand we do. But there's like most of all the departments there are relying on the data, and there was always a constant demand for it, but definitely apart from, say, the manufacturing side of it, that they are just doing it from the design perspective through like that. But the sort of post sort of analysis is then where all the other departments are then like focusing on the data and stuff. And then you'll only hear when people want to. It might say, "Oh, just to warn you, we're working on this and we want some instrumentation on it." And so we'd have to go back to the designers for the car to see where it can be plugged in and measured and stuff like that. But for the whole of how Formula One is developing through that, I wouldn't know.
So let's go back with things that you know. For example, you mentioned downforce. You mentioned a lot of things being there. Like, is there any specific algorithm, because there's always a trade-off of speed or downforce, drag, depending on the race? Is there something which you constantly have? You mentioned, I guess, depends on the track from the truck. So is this something this is you're facing every single race, doing these kinds of trade-offs or boost the performance parameters?
The basic fundamentals of how a race car works, and the more downforce you have, the more top speed you might lose and stuff like that. And then it's always trying to, don't drop, keep the top line speed up, but then keep your slow corner, your mid corner. But then that's what Tony was bringing up before, that we've sort of narrowed that down now because we've got so many models going, and the actual driving bit is just a conclusion to say, yeah, what they've done on the simulator or what they've done in CFD is right, and then that's how it is. But yeah, the fundamentals are still there of how the driver feels and with the balance, and then it's not just over one lap though, is it? Because you've got to remember that of your 2-hour race, the car changes so many in ways with your mass, your tyre wear, the weight comes down, but then you go and put different tyres on, so you've changed it all again. So they're going through all their models, but then you've got to have the strategists looking at the other 18 cars of what they're doing and things. So it isn't just a case of, okay, we run 15 laps on this tyre, and then we should change another 20 laps because other things have happened. So it's just a case of lots of things changing at that particular time. But you're hoping that all your experience and everybody in the relevant departments have gone through different scenarios, and then they can chip in and say, well, in this situation, we've covered this and we can do this.
It's a team effort at the end, right?
And that's what Tony was saying, has gone from so many people. We used to do a team photo outside, and now that whole team, you would be a department if you massed over the top. We can't fit the same area they want to do the photo every year. So the photographer's on the roof saying, like, everyone's squashing sort of thing. But yeah, it has grown phenomenal. And then even when you'd be away for a few weeks, you come back, you walk around, you go to the canteen, you go, some new faces.
Yeah.
And then you walk down, there's more building works going on, and it's just constantly expanding. And they're trying to produce that as quick as possible to make then the business a bit more successful in any area, sort of thing.
Nice. And you mentioned that how the driver feels, and we're talking about the data. We talk about technology. We know that there's a lot of information coming from the technology side. How important is the feedback from the driver? For example, I know the Max is really detailed when going back to the garage about the car performance itself. How important is that comparing with other data?
Massively important, because at the end of the day, if he's not comfortable with it, it's a distraction for him, and they're not then performing to how they were or how they are. So yeah, it's that balance of both the car feeling right, the driver feeling the car right, and having the confidence with the car. Because then they start coming back saying, I just don't know what's going on here. It doesn't feel right. And you're just like, well, then the engineers are going, well, you'll have to give me a bit more information why. I can't trust it. I can't do this. So, yeah, you've got to have that sort of feeling back from them and then to know what we can do with it.
There are situations when basically you get a response that everything is fine with the car. So just like a feeling, but it might be something you mentioned. It can be a short window, something's happening, you have some delays. So I guess this is also a challenge to really, when you have, let's say, opinion from a Max or a driver versus the data that you have. So there is something happening probably. And I guess that's the biggest challenge, to really figure out what it is.
When the driver says it's not doing it what
should.
But then the time could still be there, but you're saying, but it's fine. You're achieving this, and he'd be like, oh, okay. And, so you do get a little bit of, again, because you've got the human factor. But yeah, you've got hopefully everyone in place that they can then either change something or persuade him that everything's okay.
And interesting for me is like, now you're talking about your experience and everything you've been working on the cars as well. And there's tracks like we saw a couple of weeks ago, Monaco GP. Like you have the best car, you have the best driver probably in the world, and you're always stuck in a position because of the track. Like I'm not asking you now from the, let's say, maybe technical perspective, but from you as a fan, as someone who's in a Formula, how stressful is this? How disappointing is this having a race weekend like that, where basically 10 drivers who start in the same position, they finish the race? Is it like, discuss this on the
because it happened so early, and then it gave everybody that time to get a change of tyre, so they've ticked the box that they've used 2 compounds. And it sort of nulled the race, really. Yeah, it is frustrating, and it does happen, sort of thing. But it was then, and then it was just a shame then that the tyres could last that distance, and so it did turn into a bit of a procession sort of thing. But then, I mean, sometimes it works in your favour, because we've had it before. We had a park on the car, where we were leading and we were holding up everybody. And if it had been another track, he would have been passed like he was standing still. But then at that point, Daniel Ricciardo managed to keep everyone off. But the car was not in any good shape. It was down on so much power. And but it's the way it goes with a motorsport of that sort of caliber.
Yeah, and you mentioned the car was not feeling well. This is something that interests me personally. Maybe the audience is also interesting. We are now in the era of electric vehicles. We know that now you have turbo motors, you have EV, which boosts some horsepowers. How this technology now is working from one. If I remember, 2 years from now, there will be even more power coming from the electric side. Is this something that brings more challenges for you when it comes to, let's say, reliability, getting new data, and how do you prepare for this?
It's one of those things that you look at something new coming through, or how something has been developed, but then it's not just how you understand it and how you use it. You've got to remember your competitors doing exactly the same. So where you could just think, oh, it's okay, we'll try and manage it or do something else with it. Another team might throw more people at it, more money at it, and then find something to use it in a better way. So there's always that risk, and then you're just trying to, as something is coming through, to be on top of your game and develop it the best that team can. And the hardest bit is the integration of the departments between you as it's coming through. But we've seen it electricity powered grow so quickly, and where it will go in Formula One, hopefully it will never take over it, because you still need to see the combustion engine side of it for us as fans and spectators as well. So
the sound is, especially on the Sunday now, it will be really nice. And Tony, you are with Red Bull a lot, and how do you see the future of the Formula One? Ian mentioned now about keeping the internal combustion engines. How do you see it? What do you expect? What would you like to see in the future?
For sure, I don't want to see an all-electric engine. If it's all electric, then we might as well watch golf buggies run. It's just going to sound the same. Of internal combustion component, I think, which we can develop that maybe with more sustainable fuels. Keep that side of it going. But I think we've got to keep some sort of combustion engine to make it Formula One. Otherwise, it wouldn't be Formula One to me.
I like that answer. So maybe you don't like it, but I like it personally. And why I like Formula One, not only because of entertainment part, because you are really utilizing cutting edge technology, and you're bringing that to mass production. So a lot of things coming from Formula we see in today's car. So this is also the side of Formula One and the racing that I like, because to be honest, you have much more budget for these kinds of things, and it's entertaining. So things are there, technology is growing, and first, thank you for bringing or enabling that, and for bringing this to automotive industry. With this, I would like to thank you for your insightful answers, and I will take this opportunity to open the floor for you guys to ask questions if you have. I hope you have a lot of questions, so please be short, and let's try to take everything of these 10 minutes that we have.
No? Okay, cool. Anybody?
Thank you. What is the most challenging job when you are coming to the cities? How you are preparing the Formula One bodies and for that? Because how do you prepare tires? Because this is not the racetrack. This is a different street.
Yeah, we like I mentioned before, we make sure the sort of what we're going to run on, first of all, and the guys will come and do a check, and they might just say, oh, yeah, the road is at a different type, or we need to raise it because it might capsize, or things like that might pick up. So they look at the surface of what we're on, and the type a harder compound tyre anyway, just to handle the wear and tear of donuts and things. Yeah, apart from nothing performance-wise, we will just hope that there's nothing different at the venue that will cause us a problem. But again, it is just a case of protecting anything on the car. You'd be surprised at that speed of how much the paint get damaged and things like that. So if you are there on Sunday, you'll see some areas of the car on the intakes have got little covers on them. So it's just a case of, because we want the car looking as nice as we can to produce a show. So we just try and keep them looking good and as reliable as we can.
Thank you so much.
No problem.
Next one.
So I got a quick question about the car that you're going to use for the show run. So I know that some of the cars use replicas or some different engines. For example, I've heard that you need to heat up the engine before putting it in the Formula One car. So do we expect the Renault Clio engine in the race car on Sunday, or is it a real V10?
No, it is exactly the same replica of that era of what we raced with. So
V10?
2.4, but it is of that 2011 chassis, the RB7, is exactly the same specification of what we raced with.
Do you need to heat it up?
Yeah, because the tolerances of an engine is so tight, you don't want to turn that engine over without it being above 50 degrees. So once there's been enough heat soak in the engine, then we will crank it first before we do that. So we won't, and then we'll also put hot oil in it. We'll warm the oil. So in our equipment, we have like a big kettle, and we have a little oil tank, and then we're both warming the fluid up before we do anything to it. But it is nigh on exactly the same before it came off the racetrack.
Thank you. Looking forward to it.
Hello. Regarding the new 2026 regulations, I was wondering what kind of challenges do you face for maybe preparing a few years earlier for those regulations? And yeah, how do you solve those issues?
So when a new set of regulations come through, there's people already on it and they're looking at it to what the differences are. 2026 is a big one. I couldn't name them all, but all I know is that the engine is different. But you're already looking at that. There is already CAD models going ahead. There's data being put together of how that's going to be, of all departments, of your big factors, aerodynamics and different things. So yeah, they're already working on it. And so they're already doing tests, they're already doing simulations and things like that. So, but we do that every year. Whenever there's something, a small change or a large change, you have a group of people working on that project already. So as soon as we get to Abu Dhabi, the last event, it's already okay. When do we start the next car build? When's that first chassis going through all its processes of becoming a car, and how then all the planners are putting all the parts in together. So we all have a date of like, okay, that's going to run, or there's a fire update first at the factory with everyone gets together and they're all aiming for that, and then we leave it as late as possible. So the later you can leave developing something, sometimes has a superstition that is quicker because you've got more time on it. But then once we've got that aim of when the next test is, or the first test for the first car, then everyone is focused on driving to get enough parts for a car, for a set of spares, and the different options of the build of that spec of that car, depending on where we're going, what the temperature's like, what the track is, what your brake sort of ducts and things, your different types of settings you're going to have for that is all ready for, hopefully, when you roll out the garage, that you've got everything there. And because as soon as you start churning data through, everyone is checking then what they've just done over the last for 2026 will be like a couple of years, so they will be already on it as it matched all that amount of work that they've all been putting in.
Thank you.
And we have time for one last question. Anyone? Okay.
Hello. I read somewhere that like Formula One car has about 80,000 parts. How big is your Excel sheet? Just kidding. Just kidding. How do you handle the data? Do you just worry about sensors and what sensor is giving you, or do you have to worry about each and every one of the parts on the car, like even in the showruns?
Yeah. Luckily, it's a database, and it's a life and system database, and you have the part starts itself, and then it becomes, which is funny enough called a child, and it gets put into a parent assembly, and then that assembly gets bigger, and then that you always have an owner of that assembly. So, but then you could have 2 or 3 departments have a part in that assembly, so that you're each then, like I mentioned earlier, each part has a life in, and that database will then tell you of when that part needs a service, because some part might only have like a 300 or 400 kilometer service, but the service might be an inspection, or it might be something if they run it on a rig, or you just have to do. Everything is so you're like critical of what you do with it, of the process you have with that part. So but there's still spreadsheets I do for the spares for like the 2 cars we have out here, and then we have another kit with the same, and it's just because you just constantly got to keep an eye on that you do have enough parts just in case something will fail, even at a showrun like this. We do have it, and then it's just a case of you can't. It's hard to take everything. That's why we take 2 cars, because like your spares are then built together, so it's easier. But then there's still occasion where you want to take something just in case something has happened, sort of thing. But yeah, it's then again of what do you need? Can the car run without it? Yeah, okay. Then do we need to carry it? Or we'll just wait till we get back to the UK and then restock, rechange, and then do another service schedule of that car, and then start again. But every time it is stripped, everything checked, nothing taken for granted, rebuilt, and then it's all got a full service life of what we call it, and then it can go off and go again.
I have to give this one probably the most.
Thank you. I had a question. Obviously, the RB7 is going to run here on the streets of Sarajevo. Do you have, and don't get me wrong, I love the old car, the old specs of the engine and everything. Is there a plan of sometime going to a more newer type of car, or the newer regulations, or is there any way we could expect the RB20, RB21 or some in the next time as a show car, of course?
Yes.
Thank you.
Yeah, we are. We are looking at different ways. We'd love to be able to bring an RB19, RB20. The RB19 is the most successful Formula One car in the history of Formula One, so that is our priority, to try and get one of those running. The trouble is, with a hybrid engine, we would need to bring 30 to 40 people to every event just to start the thing up. So it's easier for us to use the RB8, and the RB8 creates more of a buzz because of the noise it makes. It looks super sexy. It's lightweight. It's small. It takes you back to that era of Formula One. But I do agree, it would be great to see a more up-to-date car. Well, there are plans ahead, so we'll be back. We'll bring one back. Cool shirt, by the way. I like that.
Thank you.
if you get to that point, probably they will apply. So that 30, 40 people easily done here. So no worries. Thank you very much for your insightful answers and everything. Just before I wrap up everything, do you have, guys, maybe any last thought or advice for those aspiring engineers here?
It's just a case of like decide what you want to do and follow it. Don't be afraid of going, changing your mind, because try and enjoy what you're doing, because you're going to be doing it a long time, and it's something that you don't enjoy. It can get really hard work, and yeah, it's just it's not for the faint-hearted. But no, just again, this is going to sound really old and boring, but just study at it and just work at it, and just worry about the more things later life of the partying and stuff, because you've got plenty of time to do it. But yeah, just is what I tell when I'm looking at CVs and I see. This is going to sound really horrible, but everyone's got a degree. So, yes, you've just ticked a box. And I know you've just gone through 4 years of hard work or more, and you're just like, oh, great. But so do more, it doesn't have to be close to the job you're doing, but it just shows me that you're willing to work outside the box. You're going to go and you're putting more time in. You're looking at something else, which shows me that then later on, if we do have something that we need developing, that this person isn't afraid to tackling something. So just to be that one to stand out a little bit more, and then just do volunteer for stuff. Try and do lower formulas of just helping, just to get that trackside experience, because. You see youngsters come through, and as soon as you put them by the car, by a driver, with the noise, they're like blue screen, and it's just like, and you go like, hello, come back, and it's just like, so it's like just a benefit to know your environment, and you also know that you might enjoy it or not. So again, don't be afraid of making chases, or just having a bit more, of look out there of what you want to do.
Thanks a lot. I think that was an excellent advice. Tony, maybe your thoughts or?
My thoughts. I came from a different era, because unlike you guys, I'm not really that intelligent. You're a lot brighter than I ever will be. But I started as a mechanic in a garage, and I'm talking about the era of James Hunt and Niki Lauda. I'm going back a long. I remember watching them as a kid. I wanted to get into Formula One. I started helping friends out at tracks, amateur formulas, got into more professional formulas, worked my way up through to Formula One, worked for Williams, and then Stewart Grand Prix, and became a number one mechanic, and then a chief mechanic, and then a team manager. So I went the rough route. You guys being all super intelligent, you can go straight there. You just got to want to do it. And like Ian said, decide what you want to do, and then just go for it. You can do it. I'll see you in the pit lane.
HTEC.